Hello, algebra students. Today we're covering section 7.4, solving rational equations. Put your name and your date on your paper. By the end of the section, you will be able to solve rational equations. You'll be able to use rational functions, and you'll be able to solve a rational equation for a specific variable. We're going to start with this example, which has numerical denominators. And what we're trying to do is solve for x, where we have x squared and a 2x, so we're probably going to get more than one answer. The first thing we want to do here is to multiply by the LCD. Okay, so I'm going to put that in my side notes. Multiply by the LCD. In this case, for 2, 15, and 10, that's going to be 30. Then we get 30 times x squared is 30x squared, but divided by 2 is 15x squared. Then we distribute the 30 over to these. 30 times 2x is 60x. 60 divided by 15 is 4, so that's 4x. And then 30 times 1/10. 30 times 1 is 30, divided by 10 is 3. So you can see that when you multiply by the LCD, it cancels all of the denominators, which is very helpful. Now we want to set this equal to 0, so I have 15x squared. I'm going to subtract the 4x, and I'm going to subtract the 3, which leaves 0 on that side, right? And then we have to factor this. So I'm going to use the AC method, because 15 times 3, that's quite big. 15 times 3 is negative 45. We want it to add up to negative 4. So I can see that's going to be 9 and 5. And I'm going to make the 9 negative. So that is going to split the negative 4x into negative 9x and positive 5x. I'm going to bring down the rest of my equation. And then I need some more space, so I'm going to come up here. From there, I'm going to do grouping. So the 15x squared minus 9x gets grouped together. The 5x minus 3 gets grouped together. So I can factor out from this first grouping a 3 and an x. 15 divided by 3 is 5, so we get 5x. 9x divided by 3x is just 3. On this one, I can't factor anything out, so it's prime, so I'm just going to put a 1, because the only thing I can divide by is a 1. Then we have this piece that's going to come into its own factor, 3x plus 1, and then we have the 5x minus 3 is the other factor. Now to solve, I have to set these equal to 0. I should have carried that along in the whole problem. So now that we've factored it, okay, so the first thing we did was we multiplied by the LCD. The next thing we did was we set it equal to 0. Set equal to 0. I'm going to label that as number 1. This is step 2. Step 3 is we factored. And now step 4 is solve for each x, or x factor. We have 3x plus 1 equals 0. If I solve that, I subtract 1 from both sides, and then I divide by 3. So x equals negative 1/3. And then we have the other factor. Let's see if I can zoom in or zoom out so I have space. The other factor that we have is 5x minus 3. We want that equal to 0. It's important that we stay organized with our work so we don't get lost because there are lots of steps. Now I'm going to add 3 to both sides. So 5x equals 3. Then I'm going to divide by 5, and x equals 3/5. And those are our solutions for x. There's a little caution that says when solving equations involving rational expressions, we must check every solution to see whether it causes 0 to appear in a denominator. It didn't matter in our last example because there were no variables in the denominator, there were just numbers. If a number causes the denominator to be 0, then it cannot be a solution to the equation, but it's instead an extraneous solution, which means it doesn't really exist. We're going to go step by step with this next question, where we're solving equations with rational expressions. So we have 2/3 plus 1 over y equals 1/4. It says note any value of the variable that would make any denominator 0. Well, the only time that we might have a 0 in the denominator is if y equals 0. So y cannot equal 0. The next step that we do is we find the least common denominator of all the denominators in the equation. So we have a 3, we have a y, and we have a 4. All together, the LCD, if we multiply those, is 12y. Step 3, we're going to clear the fractions by multiplying both sides of the equation by the LCD. So let's rewrite the equation. It's the equation they gave us, and we're going to multiply by 12y. When we do that, 12 times 2 is 24, and 24 divided by 3 is 8. So the first one is 8y. Then we multiply the next one. 12y times 1 is 12y, divided by y is just 12. If you need me to pause the video to explain this or to show you exactly what's happening, let me know. So 12y times 1 is 12y, divided by 4 is 3y. We need our equals in between. So that's how we clear the fractions, by multiplying by the LCD. In step 4, we're going to solve the resulting equation. Well, to solve for y, if I have 8y plus 12 equals 3y, to solve for y, I want to get it equal to 0 first. So subtract 3y. That gives us 5y plus 12 equals 0. Now I'm going to subtract 12 from both sides, and I'm going to divide by 5. So y equals negative 12/5. Now step 5 says, if any values found in step 1 are algebraic solutions, discard them. So in step 1 we said that y can't equal 0. Y does not equal 0. Then they want us to check it. We won't check it every time, but in this case we are going to just go ahead and check it. 1 over negative 12/5 equals 1/4. So what I did just now is I plugged this into the y of the original equation, because that was what y equaled. All right, because it's 1 over, that means the inverse of it. So I'm just going to rewrite this as the reciprocal, and it's still negative. Does this equal 1/4? Well, I need a common denominator. So I'm going to multiply the 2/3 by 4, so I get a 12. I'm going to multiply the 1/4 by 3, so I get a 12. That gives us 8/12 plus -5/12 equals 3/12. And that is true, so it checks. When you're ready, turn your page. We will do A together, and then you'll do B in your groups. Okay, for A, the LCD is going to be x squared. And x cannot equal 0 because that would cause a 0 in the denominator. Just remember that for later. X cannot equal 0. So if we get 0 as an answer, we have to exclude it. All right, so we're going to multiply by x squared, and that will clear the denominators. So 1 times x squared is x squared, and over here we have 4 times x squared, but then we divide by x, so we're just left with 4x equals x squared times 12 divided by x squared is just 12. Okay, so then we have x squared minus 4x minus 12 equals 0, right? So we multiplied by the LCD, we factored, oh no, we didn't factor, sorry. We set equal to 0. And now we're going to factor. So factors of -12 that add up to -4. That would be -6 and +2. And those both equal 0. So x minus 6 equals 0, and x plus 2 equals 0. So the opposites of those would be our solutions. X equals 6, and x equals -2. Those are our solutions, and we do not have any extraneous solutions. I'm going to pause the video, and I want you to work out B. Okay, looking at C, I recognize that y squared minus 4 is y minus 2 and y plus 2. And then we also have those in these denominators. So if we just multiply everything by that LCD, the denominators will clear. So y minus 2 times y plus 2. All right, for the first one, if we multiply this 1 times all of that, we get all of that, except the y minus 2's cancel, so we're just left with y plus 2 for that first distribution. We multiply this one, 1 times y minus 2 times y plus 2 is y minus 2, y plus 2. The y plus 2's cancel, and so we just have plus y minus 2. And in the second half, when we multiply all of this times 4, all of that cancels with the denominator, so we are just left with 4. And then we forgot to talk about what the denominator can't equal, but we'll talk about that in a minute. So y plus y is 2y, and 2 minus 2 is 0, equals 4. Divide by 2, y equals 2. There's a problem though, because this would cause this denominator to equal 0, because 2 minus 2 is 0. So this actually is a no-no and it is called an extraneous solution. I would like you to try D right now in your groups. For example E, we have to recognize that this factors into the same other factors, right? Like x squared minus 7x plus 10 can factor into x minus 5 and x minus 2. So if we multiply both sides by the LCD, we're just going to multiply by x minus 5, x minus 2. On the other side, x minus 5, x minus 2. Because what ends up happening is this cancels with this, because they're the same when you factor. So on the left side, you're just left with x plus 13. On the right side, we have to distribute to each of these. When we distribute to the 6, the x minus 5's cancel, and so we just have 6 parentheses x minus 2. And with the 4, don't forget that we have a minus, we have minus 4. The x minus 2's cancel, so we're just left with x minus 5. Now we have to distribute some more. So we have x plus 13 equals 6x. 6 times negative 2 is negative 12. And now we're going to distribute this whole thing. So I'm going to just change this to plus negative 4 so that you know that when you're distributing the whole negative 4. Negative 4 times x is negative 4x, and negative 4 times minus 5 is positive 20. Okay, so we need to call on our math toolbox right now. We multiplied by the LCD, but then we had to use all of our tools to simplify. So then we ended up distributing, and now we end up collecting like terms. So here we have a 6x and a minus 4x. That becomes 2x. And then we have a minus 12 and a plus 20. 20 minus 12 is 8. So right now we're just simplifying. At this point, we can get it equal to 0. So I'm going to subtract x. And it's okay that we're working backwards here, so that we have 13. 2x minus 1x is just x plus 8. If I just subtract 8 now, 13 minus 8 is 5, so x equals 5. Now, there's a problem because, dun dun dun, we cannot have x equal 5 because if we do, it equals a 0 in the denominator. So bummer, there's actually no solution to this because that's extraneous. And we didn't get a solution at all that would work, so there is no solution, it's extraneous. All right, so you always have to check your solutions to make sure that they work. All right, I would like you to work on F in your groups, and then we'll come back and do G. And if we have time, maybe H. Okay, on G, we have to look for a least common denominator. And if I factor x squared minus 16, it's a difference of squares. So it factors to x minus 4 and x plus 4. So that's our LCD because this fraction on the left side has an x plus 4 also. So we'll multiply it by x minus 4, x plus 4. Okay, so we'll distribute this whole thing to here. And the x plus 4's cancel, so we're just multiplying x times x minus 4. And then when we multiply this x minus 4x plus 4 to the 32, it just cancels with the x squared minus 16, so we just have 32. When we multiply it by 5, though, there's nothing in the denominator other than 1, so the 5 has to get multiplied by all of it, like so. So we're going to have to do lots of distributing for that. Okay, so let's start distributing. When we distribute here, we get x squared, and we get minus 4x. Equals nothing to do with 32. I'm going to save the 5 for a minute. So plus 5. And I'm going to distribute just this part. X squared. We have, well, actually, this is a difference of squares, so I don't really have to because that 4x cancels with this minus 4x. So then we just have minus 16, because negative 4 times 4. Now I can multiply it by the 5. So we have x squared minus 4x. If I noticed that that was a difference of squares in the beginning, it would have saved me some time and a step, but that's okay. Plus, distribute the 5, so 5x squared minus 5 times 16 is 50 plus 30, 80. All right. Can we collect like terms? Can we get everything on one side? Let's try that. So 32 minus 80. That's going to be 48 negative. And then I'll bring down the 5x squared in front equals x squared minus 4x. Now I'm going to get everything on one side to see if I can factor. So I'll just subtract the x squared, it makes it a little easier. And then we get negative 4x equals 4x squared minus 48. Running out of space, I'm going to come up here. So I'm just going to rewrite the 4x squared on the right side. And then I'm going to, actually no, I'm not going to do that. I don't want to confuse you. I'm going to add the 4x to this side over here. So then I have 0 equals 4x squared plus 4x minus 48. This would be kind of hard to factor if I was doing the AC method, but I do notice that there's a GCF of 4. So I'm going to factor out a 4. X squared plus x minus 12. Are there factors of 12 that when you subtract them you get 1? Yeah, 3 and 4. So x plus 4 and x minus 3 will give us that 1 right here that's in front of the x. And then we have 4 equals 0. Well, if I divide by 4, 0 divided by 4 is 0, so that we can ignore that for now. Then we have x plus 4 equals 0 and x minus 3 equals 0 by the 0 product rule. Subtracting 4 from both sides, I get x equals negative 4. And I add 3 to both sides and x equals 3. Now I have to check, are either of those extraneous? Well, if I plug the x back into the original equation, this negative 4 into here, that would cause a 0 in the denominator. So that one is extraneous, but x does equal 3. For your summary today, I would like you to answer these questions. What is an extraneous solution? And when do you get them? When do you get extraneous solutions? The other question I'd like you to answer in your summary is what steps you take to solve rational equations. What are some of the steps that you take to solve rational equations? And then you have some homework to do tonight.